Okay, we're in section 6.2, part 2. I wasn't planning on splitting this up into 2 videos, but the first video was sort of lengthy, so I thought I'd split it up into 2 and give you guys a mental break. So yeah, we're in example 3 now, using transformations to show figures are not similar. So if you remember, when things are similar, their angles are congruent and their sides are proportional. Okay, we don't know anything about these angles, so let's first look at their sides. We're going to look at them in order, okay, starting with what they say, AB and KL. AB is 12. Let's see. KL is 8. That gives me 4 goes into 8 twice. 4 goes into 12 3 times. Okay, BC and LQ. BC is 9, LQ is 6. That gives me 2/3 again. Okay, CD and QR. CD is 6. QR is 4, which is also 2/3. DE, RP. DE is 9. RP is 6. 2/3. Hey, I see a pattern. AE and KP. AE is 12 and KP is 8, which is again, surprise, surprise, 2/3. So these sides are all proportional, so you may think it is similar. Okay? So I'm going to go ahead and let's say green, get my green out, draw another triangle here that is B shrunken or dilated into a new triangle that I'm going to try to compare with the red one. Okay, I tried to draw that as proportional as possible. And let's give us some letters. Okay, I have A, which stays, F, G, H, and J. And if you look, this, oh, you know what? I'm going to annoy some of you and draw this one more time. Sorry. Please do not be annoyed. Okay, it's just a video. Let's see if I can draw this a little bit better. I just need it a little bit smaller. Okay, we're going to do A, F, G, H, and J. So, if you look at the green shape and the red shape, to get from one to the other, I would now need to reflect it. Okay, I think something just happened to the video, but I recovered, so we're good. So now if we look at green to red, it's a reflection. So we're looking at A, F, G, H, J. We're wondering if that is similar to K, L, Q, R, P. We're wondering if that's similar. Okay, and if you look right here, I'm not sure I can get another color that would be visible, but this part of the drawing and this part of the drawing make me think no. But let's move to the next drawing, and the book has done a pretty decent job of sketching it out for you. Okay, if you see here, I have triangle A, or not triangle, it's a polygon A, F, G, H, J, and that reflected to K, L, M, and P. Okay, you can see here that the triangles are not congruent. Sorry, the polygons are not congruent. Why, you may ask? Because the angles are not congruent. Okay, the reflection was not a good reflection. And that's really the basis for the whole why, okay? Example 4. Using similar figures. Graphic design. A design for a party mask is made using all equilateral triangles and a scale factor of 1/2. If you remember, equilateral means equal sides, equal angles, and all the angles have to be 60 degrees. Just throwing that out there to remind you. Question A, describe the transformations that move triangle A onto triangle B. See triangle A onto triangle B. What transformation needed to take shape for that to happen? And then part B, describe why triangles C and D are similar by using the given information. Okay, describe why they are similar. I'm going to change slides and everything's sort of set up for us. Part A, describe transformations that move triangle A onto triangle B. Okay, so it looks like triangle A, let me get my black pen out. Triangle A had a dilation. And if you look, this side here, this is 1 tick mark, 2 tick marks. So we went from 2 tick marks to 1 tick mark. So it was a dilation of 1 tick mark over 2 tick marks, or a scale factor of 1/2. It really is that simple. You just have to know what you're looking at. So scale factor of 1/2. Okay, and then we did a rotation. Let's look at it. So if you look at this point right here, actually this point right here, okay, we rotated it. Okay, we rotated in that direction. Okay, it would be, goodness, if you look at this being the rotating point, okay, it rotated clockwise, and we know the degree it rotated because they're all 60 degrees, all of those angles. So this was the point, and it rotated 60 degrees. So dilation by 1/2, because I went from 2 tick marks to 1 tick mark, so I cut it in half, and then a rotation clockwise 60 degrees. Okay, part B said, describe why triangles C and D are similar by using the given information. So triangles C and D are similar because all the pairs of the corresponding sides are proportional. So C and D, we went from 1 tick mark to 1/2 tick mark. So this is 1 tick mark, and they're all equilateral. Remember, that was given to us. So 1 tick mark, 1 tick mark, 1 tick mark. So that'd be like a 1. Actually, this right here, and then it was cut in half because this side right here is the median. This side is half of this whole side. So in actuality, C is 2, D is 1. We had a dilation with a scale factor of 1/2. Okay, and then all the angles are congruent because it's an equilateral triangle. All the angles are 60 degrees. So it's a dilation with a scale factor. All the angles are equal, so you know it's similar. And really that's all you need to know, that it's a dilation and all the angles are congruent. And you're done. Alright, I'm going to do this you try with you, but I need you to write everything down sort of like you did it on your own. Refer to the floor tile designs shown below. In each design, the red shape is a regular hexagon. Definition of regular. All the sides are congruent and the angles are congruent. Red is regular. All the sides are congruent and the angles are congruent. Okay, that's a definition we learned way back in chapter 1, long time ago. So your first you try question. The tile design 1 is made using 2 hexagons. Explain why the red and the blue hexagons are not similar. The red, the sides are all congruent. Okay, the blue, can't spell. The blue hexagon, the sides are not congruent, so they're not going to be proportional. Okay, that's given to us. So technically we can say the ratios are not constant. The ratios of the side lengths are not constant. Next question. Tile design 2 is made using 2 similar geometric shapes. Describe the transformations that move the blue hexagon to the red hexagon. So this one says that they are similar. So I believe we do a dilation. It got made smaller, shrunk in a little bit. We don't know what the scale factor is. We don't have any measurements. A dilation and a rotation. Number 5. Tile design 3 shows congruent angles and sides. Explain why the red and the blue hexagons are similar using the given information. So the red are all congruent sides. The blue are all congruent sides. Okay, that means that if all the side lengths are congruent in each hexagon, the ratio of the corresponding sides is constant. So if you have congruent sides over congruent sides, the red over the blue is always going to give you a constant ratio. So if we did, we'll do blue over red because it gets smaller. If you measured the sides, blue over red is going to be constant. And all the angles are marked congruent. Okay, and the definition of similar means that the sides, the ratios of the sides needs to be constant and the angles need to be congruent. And we met both of those needs in this example. Number 6, if the lengths of all the sides of one polygon are proportional to the lengths of all the corresponding sides of another polygon, must the polygons be similar? Explain. No. Even if the sides are proportional, the angles may not be congruent. And they have to be congruent for things to be similar. So even though the sides are proportional, if the corresponding angles are congruent, then the polygons are not similar. Daily homework quiz, number 1, number 2, number 3. Okay? Go to work, 2 points. Nice job today.